Hello, class, and welcome to my business optimization project. The goal of this project is to determine the pricing strategy for our burger shop. The goal is to maximize its daily revenue from cheeseburger sales. In this project, I aim to identify the ideal number of cheeseburgers to sell and a corresponding price per cheeseburger to sell that will yield the highest possible income for the burger shack. In this project, I have established a linear demand function that describes the relationship between the price of a cheeseburger and the quantity customers are willing to purchase. Um, the demand function that I did will then be used to construct a revenue function through the application of differential calculus, which we've been learning in class, specifically by finding the first derivative of the function and identifying its critical point. I will determine the quantity and price that optimizes the burger shop's revenue. So this project is to optimize the maximum revenue for a burger shack. First, what I did was define the function and the variable. The revenue function is always price times quantity. You can see it right here, R equals P times X. Uh, I put down the given data points. I chose if the Burger Shack sold cheeseburgers for $7 and they sell 100 cheeseburgers in that day. No, if they price the cheeseburgers at $7, they'll sell 100 cheeseburgers throughout the day. If they drop the price to $6, they'll sell 125 cheeseburgers. So, given this information, point one and point two. Point one is P1 X1. Point two is P2 X2, which is 7 100, 6 125. And after that, after we did the defining the functions and the variables, we have to determine the linear demand function. The linear demand function could be wrote as P equals mx plus b or y equals mx plus b, but the b is the y-intercept, so it'd be better to put the y as the p. The m is the slope, b is the y-intercept, and y and x are the variables representing the coordinates, which are 7 100 or 6 125. So the first step is to calculate the slope of the demand function. So right here, you can see P equals mx plus b. Right here, the slope is me equals zero point 0.2 minus zero point 0.1, which is 6 minus 7 over x2 minus x1, which is 125 minus 100. You do the math, and it equals negative 1 over 25. And negative 125 over 20, negative 1 over 25 equals negative 0.04. So that's the slope. The slope is negative 0.04. The next step was to use the point slope form to find the demand function P minus P1 equals M times X minus X1. I chose to use 100, the points 100 and 7. So we just plug those coordinates into the P minus P1 equals mx, m of x minus x1. You can see right there, P minus 7 equals negative 0.04, which is the slope, and x minus 100. You do the math, P minus 7 equals negative 0.4x plus negative 0.04 minus 100, because you have to times the negative 0.04 to the x, and yeah, P minus 7 equals negative 0.04x plus 4 is what you get when you do the math. P equals negative 0.04x plus 4 plus 7, because that's what it adds up to. P equals negative 0.04x plus 11 is what you get when you add 4 and 7 together. So the demand function from that when you put in 107 into the point slope form, the demand function is p of x equals negative 0.04x plus 11. Next, I formulated the revenue function, r of x equals p of x times x. You plugged in the linear. We find the demand function. We put that in, which is r of x equals negative 0.04x plus 11x, which equals r of x equals negative 0.04x to the power 2 plus 11x. So from right here, after we formulate the revenue function, we find the first derivative. And to find the first derivative, the formula is derivative over derivative of x times ax to the power n, which equals n times ax to the power n minus 1. So we know the revenue function is r of x equals negative 0.04x to the power 2 plus 11x. So to find the derivative of that, we have to find the derivative of negative 0.04x to the power 2. The power 2 goes outside the parentheses, and you times that to negative 0.04x. No, 0.04. The x is outside of the parentheses, and the power, you just subtract 2 minus 1. And then the derivative of 11x is just, you times it by 1. You times it by 1, it stays the same. And you take the x, just cancels out. The x goes away. So the first derivative is r prime of x equals negative 0.08x plus 11. That's the first derivative. r prime of x equals negative 0.08x plus 11. To find the critical points, we just put the first derivative and we equal it to 0. So the first derivative is negative 0.08x plus 11 equals 0. We subtract 11 to both sides, and we get negative 0.08x equals 11. You divide negative 0.08x to 11, and you get 137.5. Since we can't sell half a cheeseburger, this indicates that the optimal quantity is either between 137 or 138, or it's either 137 or 138.